Okay, hello everyone, welcome. Hope you had a nice weekend. A couple of announcements, reminders, things coming up before we hop into the next topic on our agenda. The most important thing I think to make you aware of is the fact that our first exam is coming up next week. So 1 week from Thursday will be our first exam. It is an evening exam, so it takes place at 6:30 p.m. I have some information about the exam posted. I can tell you that it's going to be over the first 3 modules of material. So today's stuff will be on the exam, and that's it. No more stuff after today is anything you need to worry about for the first exam. I am going to post some review materials later on this week, so there's no review materials up just yet. I'm still working on putting some finishing touches on it, but I do have review materials for you. I am going to post some review materials later on this week, so please keep an eye on Piazza. I'll make an announcement when I get those materials up for you. And then next week in class on Monday in here, we're going to be doing an exam review session. So 1 week from today, bring any questions that you have over the last, since the beginning of the semester, basically. I'll go over some stuff at the beginning of class about the exam, and then I'll basically spend the rest of the time just going over whatever problems you would like to see me go over to help you prep for next week's exam. So that's kind of the main thing that's coming up. Are there any questions that I can address about next week's exam right now before we hop in? Or any questions about upcoming assignments or schedule stuff or anything at all? Yeah. So yeah, that's one of the pieces of information that I still have not yet determined. That will be posted right here as soon as I get those room numbers. So yeah, I will have all that information for you by the time we're here next week, certainly. Hopefully sooner than that. Yeah. Any other questions that I can help you out with before we hop into some coding stuff? Okay, great. Well, I hope you're kind of getting into the swing of things. I hope you're starting to get a feel for how this class works. A couple points for us as we continue on our computer science journey. First off, I think it's sort of important to take a moment and actually reflect on how far we've already come. It may seem like we haven't come that far yet, but the truth is we actually have. It is a fact that knowing what you know now through the first few weeks of the semester, you can write any computer program that you could possibly want to write. So you could take what you know regarding variables, if statements, and for loops and go write TikTok if you wanted to. You could take those same concepts and go write ChatGPT if you wanted to. You could write Facebook if you wanted to. I don't think you would want to. It's the equivalent of saying something like, I can build an airplane out of wood. Like, yes, I can, and people used to do that and fly them all the time. But these days, I'd probably prefer to ride on a modern airplane made out of metal with all the bells and whistles and safety features and stuff, right? So that's what computer science is now. You've learned the basics, right? You've got the very most basic building blocks, and it turns out those building blocks can go very, 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 very far. But there's a lot of other stuff that is quite useful that makes, making these big, complex programs a lot more easy to understand. But you are already computer programmers. You are already very capable of making lots and lots and lots of things. So I hope you take that and feel good about the knowledge, the skills that you've already picked up. We're going to pick up a very important skill today. In fact, this is sort of another kind of note about our progression through the class. Homework assignment 2 is definitely harder than homework assignment 1, but homework assignment 3 is kind of one of the first big benchmarks for people. If you haven't felt like you've been struggling too much up until now, homework assignment 3 is usually where almost everybody struggles, at least a little bit. Arrays are a tricky topic. So arrays are definitely more complicated, I think, than anything we've talked about so far, and with the addition of, we're actually going to use loops and if statements and everything that we've been talking about so far. So you do have to have a good grasp on that stuff in order to understand arrays. But it is a very important topic. So let's dive right on in. We're going to talk about arrays today, and in order to understand what arrays are and why we need them, let's consider a simple data collection example. You know, we live in an era where if we can write it down, you know, we can collect the data, we're going to. And weather's a classic example. You can find all kinds of weather statistics for positions all over the world, but even if we just focus on St. Louis, a very simple example, I might want to track the high temperature over the course of a week. That's not a difficult thing for us to do. If I wanted to write a little program to do that for me, I could create 7 variables, one for each day of the week, and then, you know, use those variables to track the high temperature over the course of the week. That's not too bad. You know enough to do that. Let's say I wanted to extend that to track over a month. Okay, now I'm up to, you know, 31 variables. That's getting to the point where it's like, I don't know if I really want to do this anymore, but, you know, I could do it. Not too bad. A little tedious, perhaps. Okay, now I want to do it for a year, or 5 years, or 10 years, or, you know, for all of recorded time. And now we're in trouble. There's no way I'm going to sit down and make 365 variables. That's just not happening. That's not a good use of my time. It's unwieldy. And then consider if you need to change it later and figure out, you know, where one of those numbers is wrong, or, you know, go searching for a needle in a haystack trying to figure out which of those values you didn't type in correctly. It's a pain. It's a pain to have to do that. We need a way to refer to collections of data. So understanding the idea that when I talk about something like high temperatures over time, I'm referring to that as a single unit. Yes, there are, you know, many different values, but that collection I can refer to as a single unit. And an array is the first way we're going to see that we can use on computers to store collections of data. So here's an example of how we can create an array right here. We're going to start off with the basics. If I want to create a brand new array, it's just like creating any other variable. So when I want to create a variable, I'm creating a brand new variable for the first time. I start by looking at the left-hand side of the equal sign. This is just a variable name. What is this? There's a word that I would use to describe this. It starts with a T. Type. That's right. If I'm creating a new variable, type followed by variable name. Same thing here. Same thing here, except this time you've probably noticed that the type looks a little bit different. It's not just an int. It's int followed by square brackets. And after today, I really hope that whenever you see those square brackets, your brain thinks array, because that's what those square brackets represent. When I see this, my brain says integer array. It does not say int, it says integer array. Those brackets I just immediately replace with the word array in my brain whenever I see it show up in that context. So I'm creating a new array of integers, a new collection of integers called high scores. And then if we move over to the right-hand side of the equal sign, I see this word new. We've actually seen this word before. Where have we seen this word pop up? Scanner. Yeah, good. Scanner. Where I haven't seen this word pop up is when I'm creating integer variables, right? If I say int x equals 7, there's no new involved, right? Or doubles or strings. But notice that scanner, well, that's a little bit more complex than a double or a string, right? Same with arrays. That's a bit more complex than a double or a string. So here's that new word again, and we're going to see it pop up more and more often as the semester goes on. For now, we can just kind of treat it as the magic words that we need. And then here, this actually tells us the size of the array. So I have to tell you how big that array is going to be. How many things are in this collection? So in this particular case, I'm telling you that I expect 10 things to be in this collection of values. And once I have said that, once I have created this array of 10 values, this collection of 10 integers, that array is, I would call it empty, right? I think of it as 10 buckets, having 10 buckets. And it will forever have 10 buckets. I cannot change that size. So once I have made this size declaration, I can't grow it, I can't shrink it. It will always be of size 10. Which might seem restrictive, might seem a little inconvenient. We have ways that we can work around that. that we'll talk about a little bit later on, but for now I think it is important to understand that you can't change the size of this later on. So you have to think a little bit carefully about that. Another thing to note over here, notice that the size doesn't come into play on this side, right? These brackets are empty. These brackets contain a number that indicates the size. And also note that any type can go here. So this is an array of integers, but if I want to create an array of strings, I can do that. Doubles, I can do that. In fact, if we want to take a look at this little practice problem down here, an array of doubles. So type comes first. It's an array of doubles. It's a double array. So when I hear that word array, square brackets. All right, give it a name. It tells us to call it prices. It wants it to have 5 values. So new followed by double has to match the type. And then 5 inside of the brackets to indicate that there are 5 values. Everybody with me so far? Cool. So this creates what I would call quote-unquote empty arrays. They're not actually empty, but for our purposes, we don't really know what's in them, right? They're empty buckets, right? We haven't actually put any values into those buckets yet. We can do that, and we will. But these arrays, I would say, are empty. They're waiting for information. They're waiting to be filled up. What if I know what those values are? What if I don't want to create an empty array? What if I know what I want my array to have in it, and I want to create an array that already has stuff in it? Let's take a look at an example where we can do that, because that's a very convenient thing for us to do as well. Here, I'm creating an integer array called high scores. And this time, instead of using the new word followed by square brackets, you'll notice I've got some curly braces here followed by this list of values separated by commas. So these are going to be the actual contents of the array. These will be the actual values stored in the array. So what is the length of this array? What is the size of this array? 5. Yeah, it's just the number of things that I see here. So if I come out here and I add another value, right, it now has a length of 6. I've extended the size by adding another value onto it, right? But I think that leads us to another important question, which is, if I have an array, how do I ask it? How do I say, hey, how many things do you contain? What's your size, or more specifically, what is your length? So if I take the name of an array and I stick this on the end of it, dot length, that's going to tell me how many things it contains. Notice that this is always going to be the same, right? So whether I know what these values are, whether I've created the array like this, or whether I've created the array like this, right? Its length is the same. However many things it can hold, that is the size of the array. So in this particular case, I would expect this to say 6 when I run this program, because this array can in fact hold 6 things, right? If I took 1 off, it would then go down to 5. So if I know what I want the array to contain, this is a very easy and convenient way to do it. But I may not know what I want the array to contain, in which case I have to create an empty array and then fill it later. We do this a lot if let's say I'm using scanner to ask somebody to type in, right? Maybe I want them to type in the numbers that I want to go in the array. I'm going to ask you to do that on the next homework assignment, actually, assignment 3. So if we wanted to do something like that, we need to have a way of getting values into an array. And so that's what this is doing for us. If we review up here at the top, this is the line we've already seen a few times now, creating an empty array. This is actually trying to grab a value from the array, one value from the collection. So think about it. In order to grab one of the 5 things that this array contains, I have to provide an address, a position, right? I have to tell it which of the buckets in the array I am asking about. In computer science terms, that position, that address, is called an index. So when I use the word index, I'm talking about a position, an address within an array. And the first index, the first address of an array, is actually not 1, but 0. So computer scientists always count starting from 0. You may have actually noticed this. Module 0, that wasn't an accident. That's how we count. You get kind of used to it. It does feel a little weird at first. I remember when I learned about it, it felt a little weird to me too. You do get used to it. So if I have an array with 5 values in it, the first position is 0. The second position is 1, 2, 3, 4. That's my 5 values right there. Notice that there is no position 5. If I have 5 things in my array, there is no position 5. That position does not exist. Because I start counting from 0, the last position is 4. It's an important, very important thing to keep in mind as we're working with arrays. But let's go back to this example. It creates an empty array, and then the first thing that it does is it prints out the value at position number 0. Well, wait a second, we haven't put anything in here yet. This is an empty array. Well, let's run this and see what our quote-unquote empty array contains. Maybe you will or will not be surprised to see that our empty integer array is actually filled with zeros. It contains all zeros at the beginning. Same for the double array. But if I wanted to have actual numbers in it, things that aren't 0, then I need to say that. I need to do that with my code. And so here's what I might say. This is going to take the value of 99 and assign it to the array at index 0. So it's going to go find bucket 0 and then plop the 99 in there. Right? And then this is going to take a 98 and go put it into bucket number 1. And this is going to take a 98 and put it into bucket number 2. And so on and so forth. So when I come back down here and I say, all right, print out the score at index 0, well, you know, the first time it was 0 because I hadn't done anything. Then I said, all right, put 99 into bucket 0 and print out bucket 0 again. And now I see, all right, there's the 99. That's the value that lives at index 0 because I put it there, right? I told it to go there. So this is how we can store things into the array and then retrieve them back out later on when we need them. Any questions about anything that we've done so far? Yes?
Sorry, could you explain what
The index is a position. The index is a position of an array. So actually, if I go back to this example here, we can see that this is the array. These are the values contained in the array. So if I want to think about it in terms of their index, right? The 99 is at index 0. This 98 is at index 1. This 98 is at index 2. This 98 is at index, or 88 is at 3, 4, 5. So if I want to get this value of 88, I can't just say high scores. High scores refers to the entire collection, all of the values as one unit, right? The entire array. If I want to pull one value out of the array, I can't just tell you the name of the array. I have to tell you the name of the array in addition to the index, the address, the position where the value lives that I'm interested in. So if I want to get the 88, I have to say brackets 3. That says go visit the high scores array at position number 3. I want to see what that value is. That's an 88. Great question. Another question.
What if we do just print just the array of high scores with no index value?
Yeah, let's try it out. I am so happy that you asked this question. What if I just try to print out the array like this? So, you know, there's a couple things we can think about. What do we want to happen here? What do we expect to happen here? I think a lot of you are probably hoping I would see something that looked kind of like this, all the different values of the array. Unfortunately, that is not what we saw at all. I would imagine that you see something similar to this, although if you had the exact same numbers and letters here, then you and I should go buy a lottery ticket, because that would be quite amazing, in my opinion, if you had the exact same letters and numbers as me. This is a piece of information, believe it or not. It's not useful, not to us, not for this class. This is telling us the address on the computer where the array lives. Like the physical location on your computer where it says 99, 98, 98, 88. This is a physical memory address on your computer. Doesn't help us at all. Not what we want. Never what we want in this class. Usually not what we want in any of our classes. Only in very, very, very specific situations is this piece of information useful to us. Very rarely am I sitting around thinking, I really wish I knew where this array lived in physical memory. And that might have been the first time I've ever said that sentence, actually. So this is not what we want, but it's a perfect segue into our next topic, which is how do I see the contents of an array? Well, we have to revisit our good friend from last week, the for loop. I have to use a loop to visit each element of the array individually and print it out one at a time. I cannot just say print out the collection. I have to say here's a loop that's going to visit each element of the collection one at a time and print out each of those elements individually one at a time. Which you might say, well, that sounds complicated and more complex than just doing this. And you're right, it is, but that's how it works. They didn't ask me. That's just that's what Java does. So let's take a look at that. That's actually our very next topic. Test 2 actually is where I wanted to go next. Oh wait, I'm sorry, I skipped this one. I do want to touch on this very briefly before I promise we're going to talk about loops, but this is an important concept. I'm not limited to creating one array at a time. I can make as many arrays as I want. The computer doesn't care. So here you can see I'm creating 2 arrays, one for high scores, and now I have a string array for names. But not only that, pay attention to how these arrays are used, and notice that, okay, there are 5 things in this one and 5 things in this one. That's not an accident, right? The way that these arrays have been constructed and are intended to be used is that there's a relationship between them. So if I look at the value at position 0, it corresponds to this value, the same value in the same position of the other array. What I'm saying is that Jamal got a high score of 99, right? Emily got a high score of 98. Destiny got a high score of 98. So these 2 arrays together allow us to paint a bigger picture. There's a couple things going here for us, right? One other little restriction that this allows us to get around is the fact that I can't mix and match types in my arrays. So if I tell you that this is an array of integers, and then later on I say, here's a string, put it in that array, the computer's going to say, what? No, I can't do that. You told me it was an array of integers. But doing something like this allows me to have, arrays of 2 types working together. This is very, very common. You will be asked to use this technique on an upcoming homework assignment. There's a name for it. It's called parallel arrays. Parallel arrays is what this technique is called. When I have 2 arrays that are the same size, they may or may not be different types. They don't have to be different types, but they can. But they have the same size where the values correspond with one another, right? Position 0 in both arrays are related. Those are parallel arrays. All right. I promised you I was going to get to for loops. I just want to make sure I touch on this. Any questions about that before we actually do the for loop stuff? Yeah.
This is like a general question. So when I was looking at exercises part, I get confused. Like sometimes we put a space, sometimes we put a dot, like between the word.
Okay, so space versus the dot. So if you're putting a dot, then the dot is actually used to chain these things together. So the dot signifies that all of these pieces are actually connected and related. A space tells me they're 2 separate entities. So that's the distinction between a dot and a space. As for when to use which, I don't know what to tell you there except just practice. Practice, practice, yeah.
And like when I was running a demo visualizer doing this doing the 3 exercises, sometimes when I paste it in, it comes up with a new public static void array. Like it's in public users there.
I believe you, but without seeing it, it's hard for me to speculate on what you might have been looking at. If you want to come show it to me sometime, I'd be happy to take a look. Yeah. All right, so let's get back to using loops. Just as a little refresher, since I had to go off on a quick little tangent there, doing this doesn't do what we want. I want to see the contents of this names array, and this doesn't do it. This prints out some weird stuff like this. That is not what we want, not relevant to us. So what we need to do is to write a loop that's going to visit each element of the array and print out that element one at a time. And we're going to write that loop so that it sweeps the index from the very first index to the very last index. And we know what those values should be. The first index is always, 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 always 0. Always. So that's easy. That's why you see this. Int I is set to 0, right? The last index is based on the size of the array. So you may know what it is. You may say, oh, this array has 5 things in it. And you may be tempted to actually come down here and just say 5 here, right? Not necessarily wrong if there are, in fact, 5 things in the array. But I would actually encourage you to consider asking the array how big it is instead. Because it is entirely possible that you decide later on to add something to that array or take something away from that array, right? In which case that number is no longer going to be accurate. So if we ask the array how big it is, it will give us the proper answer every time. Now, you may have noticed that this says that I is strictly less than the length of the array. Strictly less than. That's very important. Again, keep in mind, I'm starting from 0. So if there are 5 things in my array, I, the index, can never be 5, right? I never want it to be equal to the length. It can be up to, but never exactly the length. I know I've already talked about that. I'll probably mention it again today. It's such an important concept. If I have an array with length x, the index of the last position is going to be x minus 1. Yeah, x minus 1. Whatever the length of my array is, the address of the last element is the length minus 1. So then this loop, how does this loop work? The first time through this loop, I takes on the value of 0. So that when I run this print statement, it says go to the names array, pull out the value at I, which is 0, and print it out. So I get the first name. Then the loop says, all right, bump I up by 1. So I is now 1. And then it says, all right, go to the array, pull out the value at position 1. Print it out. Then it increments I by 1. It's now 2. Go to the array, value position 2. Print that out. This is what's known as traversing the array, starting at the beginning and touching every single element. We do this all the time. All the time. This loop right here, this for loop I've written, cannot even tell you how many times in my programming career. Thousands, easily. Such a common operation. Draw a star next to that one. You're going to be writing it in this class many times, guaranteed. If you need to traverse an array, this is the way to do it. Where, you know, the array name might be different, but otherwise, same process. I also want to talk to you about some common issues that I see. I mean, I've already sort of hinted at what some of the common problems are, but let's take a look at what's actually going to happen if you make a mistake, because I think that's important too. And you know, it's going to happen to you, right? You're going to make mistakes. You're going to run into problems. You're going to have to fix them. So let's take a look at some common problems and see how to fix them. There's actually more than one issue here. One of them you can see right off the gate, I hope, right? Started I at 1. This is one that's just going to take you a little while to get used to. Again, we always start from 0, but notice what happens if you make this mistake. This array starts at 10, goes 10, 9, 8, 7, but I don't see the 10. I don't see it. because I told it to start at position 1, and this is position 0. So it didn't start here, it started here at position 1, and I skipped that first one. Very common mistake to make, so be careful about that. We always want to make sure we start at 0. The other one I was just talking about a moment ago, this one here, can go up to, but will never be equal to the length. But notice what happens if we do make this mistake. I see some fun red text down here at the bottom. Maybe some of you have seen this message before already, or similar ones. If you haven't seen it before, you're definitely going to see it soon, I guarantee. Array index out of bounds exception. So a lot of times people will see stuff like this and they'll just start to freak out because it can be hard to decipher what's going on here. The computer's throwing big words at you. Well, let's break it down. Index out of bounds. The index is a position. Out of bounds means that I went off the edge, right? So my array has 5 things in it, but if I ask for the thing at position number 72, that very, very clearly does not exist. So the computer says, what? I don't know how to do that. I don't know how to give you that value. The array doesn't have a position number 72. More often than not, you're not going to be off by that much. You're usually only going to be off by a little bit. You're just going to go off by 1. Just going to go off by 1. In fact, it'll tell you that. If you scroll over here, it says index 4 out of bounds for length 4. What's that telling me? That's telling me the array has a length of 4, and the index that I was trying to visit is 4. And if you've been paying attention, you know that that's not allowed, right? The last available index to me is not 4, but 3. Another thing that you can do, another very, 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 very useful tip. This is trying to tell you where the problem is, or at least where it occurred. So this right here, this looks like a link. That's because it is. This is telling me that this error occurred on line number 11. And if you click on this, it'll actually take you to line number 11. Now be careful. Be careful. This does not mean that the problem is on this line. This is where the problem was first noticed. This is where we first noticed that we had a problem. But that does not mean that it's where the problem actually happens, right? We could have set something up wrong earlier on and not actually noticed it until we made it a little bit farther on down the road. But at least we know that we're in the right ballpark. So while this could be the line with the problem, I think, if I'm, as an experienced programmer, if I run into this error and I see that it's occurred inside of a loop, my training teaches me, well, I'm looking at the loop, right? I'm going right to that loop and I'm checking it to make sure that it looks okay. I've run into problems enough times to know that loops are commonly the source of issues. So hopefully you would notice that you've got a little off by 1 error there that you can fix up real quick, and now we've got a much better looking loop to traverse our array. I really like doing examples like this though. I mean, yes, you will see errors like this, but I think it's also important to understand that as a programmer, right, my goal is to get a working program. That is true. So I do have a problem I'm trying to solve. I absolutely do not expect to write that program the first time, not correctly. In fact, I would venture to say the opposite. If I write a piece of code and it does what I expect it to do the very first time, I am immediately suspicious. I am immediately like, what? What is going on here? There's no way. I had to have made a mistake somewhere. Please, please, please get used to the idea of programmers making mistakes, because that is a fact. That is going to happen. It is so common that, to me, the more valuable programmer is not somebody who can write good code, but somebody who can fix problems in code. That is a more valuable programmer to me. There are a lot more problems that need to be fixed than nice code that needs to be written. That's just a fact. So, I hope these are useful to you, and I hope that you feel the courage, emboldened enough to try and fix some of these problems yourself when you run into them. Yes, we're here to help you if you get really super stuck, but take a stab at it yourself. You may be surprised at how much you're able to figure out. All right, about to switch to a different topic. Any questions on this example before we move on to the next? Great. I'm gonna, oh yeah, question.
Just like, how does it know when to stop with this?
How does it know when to stop?
Yeah.
So the bounds of the loop
Okay.
tell us all we need to know. This tells us the lower bound, where we start, 0, and this tells us the upper bound, where we stop. So if I is greater than or equal to the length of the array, we stop. This condition is false and the loop is over. The way that we've written this loop, though, we know that this will be true when I is equal to exactly the length. The computer doesn't necessarily know that, but we know that. Any other questions? Great question. Yeah.
I have a question about array 4.
Sure.
Why can't you put like a different index in the same like system function? Like why can't you put name 0 with high score 1?
Well, I think that's what's happening here, right? Am I misunderstanding your question?
So why can't you put 0 with names and then a different index with high score? Why can't you put high score 4 with name 0?
Okay, so why couldn't you do this?
Yeah.
So, well, the answer to your question is you can. There's nothing, the computer doesn't care, right? The computer will run this. There's nothing incorrect about this code in the sense that it will run on your computer and do exactly what you told it to. But, and I think you've asked a very important question here, right? The idea of parallel arrays, that is for us as human beings. That is a programming organizational method. The computer does not know we're using parallel arrays. The computer does not care that we're using parallel arrays. The computer is not going to keep track of the fact that Jamal corresponds with this score and Emily corresponds with this score. That is a technique that we as programmers use to help us keep our code organized. Does that help answer your question? There's nothing enforcing this besides us when we write the code. That's our job as programmers. It's a very helpful programming technique. But I'm glad you asked about it. Any other questions? Yes?
Can you explain the difference between index and
Index and the index and the length. So the index is a position, it's an address. The length tells us how many things it can contain.
So that, does the length start at 1 or 0?
The length is constant. So it doesn't start anywhere. I think of it as like an egg carton, dozen eggs, a length of 12, and will forever have a length of 12. That is an array of size 12, where the 12 things are the different little buckets, right? The index would be starting at one bucket. That's bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. The actual positions, the numbers of the buckets, those are the indices. So that starts at 0 and counts up until I reach the end of the array. Does that answer your question? I hope. Okay. I'd like to introduce, so last week we actually saw 2 different kinds of loops, for loops and while loops. And this week I'm going to show you actually another kind of loop. Although it's a variation of a loop we've already seen, it's a different kind of a for loop that works very, very well with collections, with arrays and other types of collections that we're going to see later on in the semester as well, but definitely with arrays. So we're going to take a look at a kind of loop called a for each loop. That's our next task. And it is similar-ish to a for loop, in the sense that it contains the word for, and you see the parentheses and the curly brackets. So yes, all of that is similar to the for loops that we saw last time. But what's different, you can see, is that I don't have the same pieces that I did before. The stuff inside the parentheses looks different. The stuff inside the parentheses looks different. So the for loops we were writing last week, or even the ones that we were looking at, just a few moments ago, earlier today, had 3 parts when I created them. What are those 3 parts? This is a good review. 3 parts of a for loop. First part, initialization. Second part, condition, yeah. And then the last part, increment. Increment is good enough. Increment to me implies going up by 1, which is what we do like a lot of the time, but it is possible to go up by other values or down. So while increment is mostly correct, I prefer to use update as the name for the last one. But I do understand increment as the answer there. So yes, the for loops that we've seen have 3 parts. Those 3 parts. This one only has 2. This one only has 2. So they work differently. They work differently. The way that the for loops worked that we were just looking at, this looped over the index. So I represented each position, each index. So here, this array has 5 values in it, has a length of 5. So the first time through this loop, I is 0. The second time through the loop, I is 1. Then I is 2. Then I is 3. And then finally, I is 4. And then we're done. So I takes on the value of each of the indices. I'm iterating by position. I'm iterating by index. For each loops are used to iterate by value. So the way to interpret a for each loop, there is no index here. There is no index involved here at all. I'm not using the positions. I'm not using the index, right? I'm saying the way I would interpret this for loop is I would say for each value in the high scores array. So the first time through this loop, value would not be 0, would not be the